It started in the middle of the night. Under a sky heavy with moisture, rain began to fall across central Texas. At first, it sounded ordinary, but within minutes, creeks surged. Rivers rose faster than anyone expected. Roads vanished beneath moving water. By dawn, entire communities were cut off. In the Texas Hill Country, the Guadalupe River exploded out of its banks, climbing meters in just hours. Campgrounds were swallowed. Families scrambled for higher ground. Rescue helicopters lifted people from rooftops as floodwaters tore through valleys that had been dry only days before. This was not just a storm. This was the collision of heat, moisture, geography, and a changing atmosphere, all converging over one state. This is Texas, and this is what extreme weather looks like when it no longer takes turns. Texas at the crossroads of extremes. Texas occupies a unique position on the North American continent. Few places on Earth sit at the intersection of so many powerful weather influences at the same time. To the southeast lies the Gulf of Mexico, a vast reservoir of warm water and moisture. To the west, dry continental air pushes in from deserts and high plateaus. From the north, cold air masses occasionally plunge south. Above it all, the jet stream frequently passes directly over the state, steering storms and amplifying instability. This geography means Texas does not experience one dominant weather threat. Instead, it faces prolonged heat waves, violent thunderstorms, destructive hail, tornadoes, flash flooding, river flooding, and tropical systems, often overlapping and sometimes back-to-back. In recent years, scientists and meteorologists have warned that these events are becoming more intense. A warming atmosphere can hold significantly more moisture, and when storms develop, that moisture has to fall somewhere. In Texas, it often falls fast. The flood that changed everything. On July 4, 2025, a powerful storm system stalled over central Texas. Moisture streamed in from the Gulf, while unstable air fueled intense thunderstorms. What followed was catastrophic. Rainfall rates overwhelmed the landscape. In some areas, months' worth of rain fell in a matter of hours. The Guadalupe River rose with terrifying speed, turning from a calm river into a destructive wall of water. Campers were trapped. Vehicles were swept away. Emergency responders worked through darkness and rising water to reach families stranded by floods that moved faster than warnings could travel. Meteorologists later explained that events like this are becoming more likely as climate-driven warming increases the amount of water vapor available to storms. When conditions align, rainfall becomes extreme not just in total amount, but in intensity. This was not a slow flood. It was a sudden one, the most dangerous kind. 3. When the sky turns to ice. While Central Texas battled floodwaters last year, other regions faced a very different threat. Severe thunderstorms erupted across northern Texas, producing massive hailstones, some as large as golf balls. These storms tore across communities with winds powerful enough to shatter windows, damage roofs, and destroy vehicles. Residents were told to stay indoors immediately. The danger was not hypothetical. Hail of this size falls at extreme speeds, turning ice into airborne projectiles. In several areas, damage was widespread. Cars were dented beyond repair. Roofs were punctured. Power lines were brought down. This kind of hail forms only in exceptionally powerful thunderstorms, fueled by intense updrafts and abundant moisture. And in Texas, those ingredients are becoming more common. 4. The heat that came too early. Long before the floods and hailstorms arrived, Texas was already under stress. An early season heat wave settled over the state weeks ahead of schedule. Temperatures climbed rapidly and they stayed high. Days above 100 degrees became common. Nights offered little relief, with warm air lingering after sunset. Public health experts warned that early heat waves are dangerous. People are less acclimated. Infrastructure is not yet prepared. Power demand spikes before systems reach peak readiness. The early heat also dried out soils across much of the state. Vegetation lost moisture. Rivers dropped. The land hardened. That dry ground would later play a critical role in worsening flooding, as hardened soils were unable to absorb sudden heavy rainfall. Heat, drought, and flooding were not separate events. They were part of the same system. How extremes amplify each other. Extreme weather rarely acts alone. In Texas, prolonged heat dries the land, reducing its ability to absorb rain. When storms finally arrive, water runs off rapidly instead of soaking in. Warm air from the Gulf carries enormous amounts of moisture inland. When that moisture collides with frontal boundaries or dry air, storms intensify quickly. Changes in jet stream patterns can cause storm systems to slow down or stall, dumping rain over the same areas again and again. These interactions create what meteorologists call compound events, situations where one extreme makes another more dangerous. Flooding becomes worse after drought. Storms become stronger after heat. Recovery becomes harder when events arrive back to back. The human cost. Behind every warning polygon and rainfall map are real people. Families who lost homes to rising water, drivers trapped on flooded roads at night, farmers watching crops fail under relentless heat, communities cleaning up hail damage only to face another storm days later. These are not abstract risks. They affect health, livelihoods, housing, and safety. Emergency responders across Texas have been stretched repeatedly, rescuing flood victims, responding to storm damage, managing power outages, and preparing for the next threat before the last one fully ends. Why forecasting is getting harder. One of the most troubling aspects of modern extreme weather is uncertainty. Forecast models can often identify the potential for dangerous conditions days in advance, but predicting exactly where the worst impacts will occur and how severe they will be has become more difficult. Warmer oceans, shifting atmospheric patterns, and increased moisture introduce variables that make storms harder to pin down. Small changes in track or timing can mean the difference between heavy rain and catastrophic flooding. Meteorologists are increasingly forced to warn broad areas, knowing that some communities may be hit far harder than expected. That uncertainty makes preparedness more important than ever. Texas is a warning signal. It offers a glimpse of what extreme weather looks like when multiple hazards collide in a warming world. Heat that arrives earlier and lasts longer. Storms that produce destructive hail and violent winds. Rainfall that overwhelms landscapes in hours. Floods like the one in 2025 that move faster than people can react. These are not isolated incidents. They are patterns emerging from a complex climate system under stress. Understanding those patterns does not prevent disasters, but it can reduce their impact. Why weather literacy matters. For individuals, understanding risk means knowing when to seek shelter, when to evacuate, and when not to drive. For cities, it means building drainage systems that can handle extreme rainfall and power grids that can survive prolonged heat. For emergency managers, it means planning for scenarios that were once considered rare. Weather literacy is not about fear, it is about preparation. Texas stands on the front line of extreme weather, where heat, water, and atmosphere collide with little warning. What happens here matters far beyond state borders. It shows how quickly conditions can change, how dangerous compound events can become, and how important it is to stay informed. At Extreme Weather Lab, we track these events not to sensationalize them, but to understand them and to help people recognize the risks before they arrive. Because in a world where extremes are intensifying, knowledge is one of the few defenses we have. And now we want to hear from you. Where are you watching from?